All right, welcome to this third exercise. We are still solving non-homogeneous differential equation by using the variations of parameter. So in this exercise, we are required to solve this second order differential equation subject to this condition y of 0 equal 1 and first derivative of 0 is minus 1. All right, let's start. What's the homogeneous equation associated to this non-homogeneous equation? The homogeneous equation here is d squared minus d minus 6 y equal 0. The auxiliary polynomial is p of lambda. This is, so as you all know, this equation is similar to this, minus 6 y prime minus 6 equals 0. Minus 6 equals 0. This polynomial is lambda square minus lambda minus 6 is equal 0. If you factorize this, this is lambda plus 2 times lambda minus 3 equal 0. Right, this means lambda is equal minus 2 or lambda is equal 3. And from this, we can write y1 is equal e to the power minus 2t. y2 is e to the power 3t. So this means that y0, the homogeneous solution here is a times e to the power minus 2t plus b times e to the power 3t. A, B are in R. All right, this is what we have, the homogeneous solution. Then let's look for the particular solution by the variations of parameter. So using the variations of parameter, we know that yp is equal u1 of x times y1 plus u2 of x times y2. So the variation of parameter says that u prime 1 y1 plus u prime 2 y2 is equal 0, and u prime 1 y prime 1 plus u prime 2 y prime 2 is equal the left hand side of this equation. This is 5 times e to the power 3t. All right. This can be written as the following. The matrix is y1 is e to the power minus 2t. The derivative is minus 2 times e to the power minus 2t. y2 is e to the power 3t. The derivative is the following. This multiply u1 prime and u2 prime. And this is 0, 5 times e to the power 3t. All right, let's call these guys omega. And we want to solve for u prime 1 and u prime 2. So u prime 1 is just omega 1, the determinant of omega 1 over the determinant of omega. So the determinant of omega 1 here, we start with the right side. This is 0, right? 5 times e to the power 3t. And the second column here is e to the power 3t, and 3 times e to the power 3t is divided by the determinant of e to the power minus 2t minus 2 times e to the power minus 2t, e to the power 3t, 3 times e to the power 3t. If you multiply, you find this determinant. This is 0, and this is minus 5 times e to the power 6t divided by, so the determinant here is 5 times this. So the 5 will vanish, and we remain with minus e to the power 5t. So if u prime is equal minus e to the power 5t, it means u1 will be minus 1 over 5 times e to the power 5t. All right, we moved to the second one. Second variable is this. This is omega 2 over the determinants of omega here. For omega 2, we start with the first entry, right? So this is e to the power minus 2t, and here is minus 2 times e to the power minus 2t, and here should be 0, 5 e to the power 3t. All this divided by omega. We already know omega. Omega is computed here. So this is 5 e to the power t. So here we cross multiply this determinant and we have 0, and this one is 5 times e to the power t over 5 times e to the power t. This is just 1. So u prime 2 is 1. It means u2 is t plus d. All right. Yp is given here. So this is u2 y1. u2 is minus 1 over 5 e to the power 5t times e to the power 5t plus c. All this multiply e to the power minus 2t plus u2 is t plus d times e to the power 3t. So if we expand this, or if we sum this to the total solution, is the particular solution plus this one. So if I expand this, this is yp plus y0. This, if we expand this, this is minus 1 over 5 times e to the power minus e to the power 3t. The second, and this part is just t times e to the power 3t plus c times e to the power minus 2t plus d times e to the power 3t plus this solution, the homogeneous solution. This is a plus times e to the power minus 2t plus b times e to the power 3t. There's a typo here. I can't use two different variables. I'm using t here because you can see here that from the equation we have t. The t is our variables, okay? We can't mix two different variables. That is wrong. That's why I want to call your attention on this, okay? You should avoid using two different variables. I also fall in this trap. So make sure you avoid this. This should be t, and this should also be t, okay? You should not use t and x at the same time. It should be only one. And in this case, you're already giving t. So you should only use t as your variables here. All right, this is what we have as a general solution. The general solution can be reduced as follows. This is, let's first write this first two terms. This is 1 over 5 times e to the power minus 2t. Second term is t times e to the power 3t. And you can see here that a and c can be factorized, and we have alpha times e to the power minus 2t. This and this can also be factorized, and we have beta times e to the power 3t, okay? So remember here I said for alpha, alpha is a plus c, capital A plus capital C. The sum of two constants is another constant. And for beta here is b times d. So sum of two constants is another constant, with alpha and beta in R. All right, this is the final solution, but we still have to use the condition here. For the initial condition, we say that alpha y of 0 is equal 1. What does that mean? If we substitute here y of 0 equal 1, then the equation becomes minus 1 over 5 plus alpha plus beta is equal 1. Secondly, the second derivative of y is equal minus 1. This means if you take the second derivative of this guy, this is 5. If you take the first derivative of this guy, this is 2 over 5. And we apply 0, it becomes 2 over 5. And the first derivative here gives 1. The second derivative we give 0. And here we have minus 2 alpha minus plus 3 beta is equal minus 1. Okay, everyone can solve this algebraic system of equation. This is a straightforward to a system of two equations with two unknown. So this gives alpha equal 6 over 5 and beta will give you 0. Okay, so if you sub here into this equation, beta is 0, alpha is 6 over 5 minus 1 over 5. So 6 over 5 minus 1 over 5, this gives e to the power 1 over 5 over 5. This is minus e to the power minus 2t plus t times e to the power 3t. And this is the final state. All right, I hope you were able to follow me and that you can repeat this by yourself. You can just follow the procedure, and I guess it is clear and you don't have any problem with the variation, using the variation of parameter method. So this was all for the tutorial. So thank you.